Previously, I explained to you how to dispel two paradoxes of quantum mechanics by adopting the idea of relative being instead of the view of own being, a substitution that is common to both Buddhism and certain interpretations of quantum mechanics. Now I will try to make sense of the so-called indeterminism of quantum phenomena by the same substitution of relative being for own being. I first start with some history. The first moment in which it became clear that quantum physics is an indeterministic physics was when Max Born published his so-called probabilistic interpretation of the wave function, or probabilistic interpretation of the state vector. According to Bohr, quantum mechanics doesn't describe, the trajectories of particles, and it doesn't enable us to predict the precise point at which we will find a certain particle. Quantum physics describes only the probability of finding a particle in certain points, and nothing more. So his sentence is, one gets no answer to the question what is the state of a particle after the collision, but only to the question how probable is a specified outcome of the collision. Probability, but not strict determination. And of course, Born said, here the whole problem of determinism comes up. Is it possible to hold determinism in quantum mechanics or not? And does it mean that in quantum mechanics phenomena have no cause at all? It would be puzzling. And you know that Buddhists usually don't like this very much. When you tell them, oh, in quantum physics, an event has no cause, they say, oh, that's not possible. We don't believe that it's possible that an event has no cause. So it's a problem. Yet, Werner Heisenberg, almost the same year, a little bit later, the next year in fact, in 1927, said exactly that. He said, quantum mechanics establishes the ultimate failure of causality. Causality is finished. Quantum mechanics has disposed of it. But then he made a nuance. What do I mean when I say that quantum mechanics establishes the final failure of causality? He said, in the law of causality, and here he quotes the law of causality. The law of causality says that if we know the present precisely, then we can calculate the future precisely. According to Heisenberg, what is missing in quantum mechanics is not the deduction from the past to the future, but it's the possibility of knowing precisely the past and present. Since we cannot know precisely the past and present, then the inference from the past and present to the future cannot be made. So in the law of causality, what is missing is not the connection between past and future, but it is the knowledge of the past or the knowledge of the present. So here you feel the nuances about this idea that causality has disappeared in quantum mechanics. But we'll come back to that later. You know, one popular picture to explain indeterminism. This popular picture was imagined also by Heisenberg the same year, 1927, and it's the so-called picture of the disturbance of the object to be measured by the agent of measurement. For instance, you send a little electron by this gun that is at the left of the picture, and then there is a light bulb that sends photons, and the photons bounce on the electron, and by bouncing on the electron, they are recaptured by a microscope or telescope, and then thanks to our knowledge of the position of the photon, we can deduce what was the position of the electron. Okay? So until now, things are okay. We use light to know the position of the electron. Unfortunately, if we want to know precisely the position of the electron, we have to send a very energetic variety of light with very short wavelength and very high frequency and very high energy. In this case, we know very precisely the position of the electron. But unfortunately, the more energetic the photon is, the more disturbance we impose to the electron. And the electron bounces anywhere, and we don't know where. And so we know the position of the electron, but we no longer know where it is after the collision. We no longer know the velocity of the electron after the collision, and therefore there is an extreme indeterminism that is imposed by our measurement. Now you could say, okay, maybe there is complete determination of things out there, independently of us, but unfortunately our measurement apparatus imposes a disturbance on it. And it's exactly this way that Heisenberg presented the experiment for the first time. But later on, Bohr said, how can you say what was the electron before the measurement? There is no meaning in this idea that the electron had a position, we didn't know which one, and then suddenly we send a photon, it disturbs the electron, and then the velocity of the electron is completely modified. In fact, the only thing we know is the byproduct of this collision, nothing more and nothing else. What occurred before and what will occur later is completely out of reach. So, instead of saying that measurement imposes a disturbance on the processes that have an own being, then he said that what exists is only the phenomenon itself, the phenomenon of collision, the relation between the object and the measurement apparatus. There is an indivisible phenomenon, he said. There is indivisibility between what we want to know, namely the position of the electron, and the means by which we know it, namely the photon that we send onto it. Okay? So there is no longer disturbance. There is indivisibility of the phenomenon. Okay? And there is non-duality between subject and object here. Okay? Just like in the Madhyamaka Buddhist conception of knowledge. Okay, but on the other hand, this very collision of the photon imposes a lack of knowledge of the causal sequence of the event for the electron. So we could say that the indivisibility of phenomena is deeply connected with the acausality, with the absence of possibility of ascertaining a causal connection between two events. So there is this connection between indissociability of the phenomena with respect to the experimental context and lack of knowledge of causality. So that means that there is a deep relation between relativity and absence of knowledge of causality. First of all, I would like to quote some sentences by Nagarjuna, which shows that Buddhism is much less, I would say, favorable to causality than usually said. According to Nagarjuna, causality is a very tricky concept because it supposes that there is a productive cause and a produced effect. But in order for a productive cause to exist, it has, according to Nagarjuna, to exist intrinsically. But on the other hand, he has criticized very thoroughly the very idea of intrinsic existence and replaced it with the idea of relative existence. Therefore, the concept of an absolute cause, of an absolute effect, is completely criticized and even dispelled by Nagarjuna. For instance, he said, when neither existence nor non-existent nor existent non-existent are established, how could one propose a productive cause? So that means that if there is no intrinsic existence, there is no intrinsically existent cause. So you see, Buddhists are more critical about causality than usually said. Now, let's try to understand how comes that it's so impossible to predict future events in quantum physics. To understand that, I start with a sentence and a reflection by Sir Karl Popper, the celebrated philosopher of science. He said, if self-projection is impossible, then a predictor cannot predict the effects of its own movement. You cannot predict the effect of your own movement because you don't know what movement you will do next. In order to know which movement you will do next, you would have to be an observer of yourself. If you coincide with yourself, you don't know what you will do next. You do it, but you don't know. Okay? So, this explains why you cannot predict yourself. But if you interact so deeply with what you want to know that the effect you have on what you want to know is connected with what you will do, then you cannot, in the same way that you cannot predict your own actions after a certain point, you cannot predict the future of the things that you are studying after a certain point. So, in fact, since self-prediction is impossible, the prediction of the things that interact deeply with yourself is also impossible. So that explains why quantum physics is indeterministic. So, can we conclude that events have no cause? No, only that they have a relative cause, namely a cause relative to what you do in order to show the very process you want to predict. Okay? And you have here the quote of a philosopher of physics who said exactly that. In microphysics, causes of an event are relative to the observation of this very event. So there are no intrinsic causes. The causes are relative to what you do in order to unfold them, to manifest them. In order to manifest a cause, in fact, you change a cause and you contribute to the cause. So there are no absolute causes, there are relative causes.